All right, you guys, we're going to be looking at the measures of center lesson today. Should be pretty straightforward. I'm going to use technology to kind of help speed up the process a little bit, which is a nice change of pace because normally I make you do everything by hand first. So you're welcome, right? But we're going to look at its mini lesson on basically statistics and measuring center. Okay, so essentially, we have a population of information. We have a sample of data that we take from the population. Okay, so right now we're going to be looking at very basic examples of data. So we'll be taking the minutes we spend on homework each night for a week straight. Okay, we're not going to get too crazy with things. Data entries range from say like 5 to maybe 20 points of data. Okay, so the three things we're first going to explore are measures of center. Okay, hopefully you've heard all these terms before: mean, median, and mode. If you haven't, mean is the average, median is the middle number when arranged in numerical order, and then the mode is the most common. Okay, if there is not a repeated value, then there is no mode, and that's totally okay. All right. So we're going to take a look at this first situation. This one we are going to do by hand just because I'm a big jerk. All right. But the mean's probably the easiest. All right. So all we're going to do is we're going to add up all of these. So we have 50, 30, 25, 20, 40, 35, 35, 10, 15, and 35. So we add up all those entries and we divide by 10. All right, we wind up with a mean of 29.5. All right. For the next piece, it's typically easiest to arrange from smallest to largest. So I'm going to kind of go through the list: 10 to 15, then we have 20, 25, then we have 30, we have 35, 35, 35, 40, and 50. Okay. So when arranging your information for the median, it's typically easiest to go smallest to largest. Then we can kind of go through. Notice we have 5 entries here. We have 5 entries here. So when there's an even number, remember the median is the average of those two numbers. Okay, so when we look at this, I'm going to do 30, sorry, that's a horrible 3, plus 35 divided by 2. So I'm going to get a 32.5 as my median. With an odd number of entries, it's just going to be whatever that middle entry is. So for example, if we had 1, 2, 3, 4, 5, the middle entry would be our median. Okay. If there's an even number of entries, we're going to take the average of the middle two to get our median. All right. Last but not least, the mode is the most common. In our set of information, I see a 35, a 35, and a 35 3 times. So my mode in this case is 35. Hopefully you guys remember those measures of center. That's something you've been doing for quite a while now. We're going to move into some more complex calculations on this next slide. So the next 3 we're looking at are range, variance, and standard deviation. So this gives us a little bit better idea of our spread in our data. So it gives us kind of this more analytical piece we could use to describe what's happening in our data. Just, besides this is the most common, or this is the middle, or this is the average. Okay. This is starting to get at how much our data is spread out. Okay. Range is obviously the highest to lowest value, how much or how wide that difference is. Variance. All right, notice this calculation looks uber complex in terms of things. All right, this is where technology is going to kind of give us a little leg up in terms of speeding up the process. So those formulas are there, but just know we're going to use our calculator to kind of help determine things and figure things out. Okay. Keep in mind, these are the two formulas for population standard deviation. So population standard deviation. The only difference if we're looking at a sample standard deviation is we're going to divide by n minus 1. Okay. And honestly, in this class, you don't really need to know the difference, but I'm going to show you how they differ when we run those calculations in our calculator. Okay. And then the standard deviation is just the square root of, you notice my variance. So the variance and standard deviation, if you can get one, you can get the other. If you know one, you can get the other easily. All right. So let's dive right into things. All right. Find the range, standard variance, and standard deviation of the sample scores. Okay. We'll actually be able to see on our calculator how to do this. Okay. Both sets have a mean of 84.2. Okay. So that's super important information. So we could run through the calculations and do the 85 minus 84.2 squared plus 76 minus 84.2 squared, like the formula says above. Okay. Or what we can do is we can go right to our calculators. Okay? And we're going to type these two in to L1 and L2. Okay? So if you grab your graphing calculators, you want to hit stat, which is right in the middle, and we're going to edit our list. Okay. And if you notice, L1 and L2 are completely set up here. If you want to pause the video and enter that information, you're welcome to. I'm going to move on. Okay. Once you have your data set up, you can quit. So just do second mode, get to your home calculation screen. From here, we're going to run those numbers. So we go back to stat. In the calculate list, you have all of the programs your calculator is going to run. We've been here before in the year. The one we skipped over was the one variable stats, and that's the one we actually want to run. Okay. This is a super easy program to run. You just want to make sure the list of data you have is the list you're actually calculating. So we're going to do that group A first, which is awesome. All right. So if you notice, when you run the calculation, there are two values here. Okay. Hopefully this symbol looks familiar. This is your population standard deviation. This number right here is your sample standard deviation. Notice it's slightly higher. Okay. What it does in terms of the calculations, remember we're dividing by n minus 1 with the sample standard deviation versus n. So it makes sense that it's going to be a slightly higher number. It gives a more unbiased read on your data. Okay. So just make sure you know the difference between the two. If we're looking for a population standard deviation versus a sample standard deviation, those are the difference between the two. You guys will actually notice on the bottom of your screen some other information pertaining to this. We'll get to those in a second, but right now we're just looking for variance and standard deviation at this time. Okay. So for the purposes of this problem, they're looking for that sample standard deviation, which is 6.3 or about 6.3. So if we want to find these three pieces of information, range, variance, and sample standard deviation, we said it was about 6.3, correct? Okay. If we take that value and we do square it, right? All we're looking for in this case, if you want to, grab that entire value from your calculator, you are more than welcome to. But if you honestly just want to take 6.3 and square it, that's totally fine. Not a super big deal. So when we square 6.3, we get 39.69, correct? All right. From there, We want to calculate our range. Our range is just our highest to lowest value, okay? So we're looking at our lowest value is 76, our highest is 92. So our range in this case is 16, okay? We can do the same thing for part B, okay? So we'd go back to our calculators. All right, we'd run, whoops, gotta set down the marker before I try to do that. We'd go back to our calculate screen, we'd run our one variable stats. Then keep in mind, we wanna make sure it's L2, not L1. So I'm gonna hit second number 2 to get my list 2 here, and then I'm gonna generate that information. Notice again, we have that same idea, population standard deviation versus sample standard deviation. So we're going to use that 12.8 number in this case. So we have our range, our variance, and our sample standard deviation. Excuse me. Oh, I already forgot what it was. 12.8 about. All right. So we're going to do our 12.8. If you guys remember, how the heck do we get our variance then? Well, we take our standard deviation and we square it. So we wind up with 163.84. All right. And then our range, again, looking at our data, the lowest to highest value in this case is, just kidding, that's not our lowest, 68 was. So 68 to 98 is 30, okay? So a lot of the questions, we're gonna run these, you'll run 2 sets of data and then you're just gonna compare. So if you notice, first set of data, this sample standard deviation is 6.3. The second sample is 12.8. So you notice, if we're asked to describe this information, compare the standard deviations, well, the deviation or the range on the second set of data is much higher, which means the data is much more spread out. The data in part A is much more confined or clear and concise, okay? So this is one way to measure spread, range, variance, standard deviation. The other way to do it, you might have done before. This is a really quick way and it kind of just makes sense for a lot of people. So we've used our mean, median, and mode, which is our medians and our lower and upper quartiles, okay? This is basically something you've probably done in middle school, but basically you break your data into quarters. So a quarter of my data is in the lower quartile, the mean, second, third, fourth quartiles, all right? Again, we can use our calculators to help kind of speed up this process, okay? So we have our data here. I actually already went to my calculator to kind of plug this information in. Again, if you guys want to pause the video and type this in, you are more than welcome to, but I believe I set this up in my list 3, okay? So you can pause the video, enter the information from this problem if you want, but we're gonna go to stat, calculate, one variable stats. This time I'm running list 3. All right. This time, instead of using the range, standard deviation, and variance, what we can do is we actually can scroll down. And if you notice, check this bad boy out. Hey. So on example 3, we're given basically all the information for our 5-number summary. Okay. So you can actually write it out and figure out your median. Your quartile 1 is the median of your bottom half. Quartile 3, excuse me, is the median of your top half. And you can figure it out that way. Otherwise, like I said, we can use technology to kind of help speed up the process. So when we come back here, we know the minimum of our data is 10. We know the maximum of our data is 21. The median based on our calculator use is 17. Our lower quartile is 13.5. It's between 13 and 14. And then our upper quartile, again, since we have that even information is going to be 19.5. It's between 19 and 20. Okay. So just so you know, sometimes we denote lower quartile as quartile 1, and we use quartile 3 to denote the upper quartile. So basically what it's saying is a quarter of our information is here, a quarter is here, a quarter is here, and a quarter is here. So when it says interpret the 5-number summary, there's not really like anything super analytical right now you have to figure out, but that's all you're going to see. All right. Very last question, we're going to be looking at outliers on our information. So we're going to do the same thing we just did. Again, we have a much larger set of data, excuse me, and to kind of get the problem started, we're going to run those one variable stats again. So like I said, it was already set up in my list. If you want to pause the video and set it up, you're more than welcome to. Pre-programmed my calculator for list 4 with the information in this problem. And I'm going to run my calculation. I can scroll down and I'm able to get the information for my 5-number summary. Okay. So I'm going to come back to the screen. We essentially have 10 is our minimum, quartile 1, median, quartile 3, and maximum. So our maximum is 65, our median is 21, quartile 1 is 15, and quartile 3 was 25. Okay. When determining outliers, you guys, we want to compare what's called our interquartile range. Okay. So between 25 and 15 is what? 10. All right. So half of our data is in this range of information. Okay, 25 to 15. Okay, our interquartile range is 10. All right. To determine outliers, what we do is we take 1.5 our interquartile range, which in this case, 1.5 times 10 is going to be 15. All right. So we're going to do our lower quartile and we're going to subtract 15, which in this case is 0. We're going to take our upper quartile and add 1.5 our interquartile range. We're going to add it to that upper quartile, which is going to be 40. Okay. So outliers are going to be outside of those numbers. So when I look at my data, there's nothing lower than 0, which is fine. Perfect. Good deal. Okay. But when I look at my information, I see that 65 is way bigger than 40. That's an outlier in my information. Okay. So you can kind of see the impact of an outlier. And if you want on this next part, you can run your calculations with these, but to kind of shorten things up, we can kind of understand what's going to happen normally. Okay. So if we have all of our information and then we have something way out here, our mean, median, and mode are going to be skewed, or sorry, rather, our mean is going to be skewed this way because of this outlier. If I remove, then my data is going to have a more realistic center, if that makes sense. Okay. So we can run those calculations and see that our determinant, but basically what's going to happen is your range and your standard deviation are going to be much smaller if we eliminate that outlier. Okay. Those outliers have an impact on our mean, kind of stretches it out. That's why when you look at like housing data, they always talk about the median housing price, not the mean, because all of the mansions out in Hollywood that are like $100 billion, obviously that's an exaggeration, but those have a major impact on the average of your data sets. All right. The rest of the time is yours. Try to get 1 through 11. Today is pretty straightforward in terms of things.